All right, lesson 3.6, question 1. I'm going to move this out, and let's move this over. All right, so we're going to write the augmented matrix. I'm going to copy the question down first. We have 2x plus y plus 2z equals 6, 4x plus or minus 2y minus z equals 4, and then x minus 2y minus 9z equals -6. So the augmented matrix, what you're going to do is you're going to write down the coefficients here. Okay, so I'm going to make a matrix. So my coefficients here, my x's are lined up, y's are lined up, z's are lined up, numbers. So it'll be 2, y's 1, z's 2. Then my solution to that equation 6, 4, -2, -1, 4, 1, -2, -9. So I'm just writing down my coefficients for my variables and my terms there. So this would be 2. So it's not going to let me tab through. 1, 2, 6. And then I can read off my paper here. 4, -2, -1, 4. And then I've got 1, -2, -9, -6. So I check answer. Good job. 2, write the augmented matrix. So the first thing I want to do is I want to make sure they're in order. So I've got 2w plus 8x minus 3y plus z equals 30. Next, I've got 4x plus y equals 20. And I'm just going to go off. I'll write it down later. So I've got 2w, so I'm going to put 2 there. 8x, 8. And notice the variables are lined up. That's what I want. -3. Z is 1, so it'll be 1z, and then 30. Now on the next one, I'm missing a w, so I'm going to put 0 there. For 4x, I'm going to put 4. For the x, see my x's, or my w is my first column, x's, y's, and then z's. Y, I've got 1y, 0z, so that's going to be equal to 20. Next one, I've got 1w, 1x, -4y, 0z, because there's no z's there, and then -9. And the next one, I've got -1, 8x, -1, no z's here again, and that's 25. All right, so perform the following matrix operations. And so I'm going to do 1/4 of R1. That means you can either think of it multiplying the row 1 by 1/4 or dividing it by 4. So 1/4 times 4 is 1. 1/4 times -20 is -5. 1/4 times -8 is -2. 1/4 times 28 is 7. And then the other rows, the other elements are going to stay the same. So 7, -2, -4, 0, -1, 0, 3, and 5. All right, so on this one, we're going to do -5 times R1 plus R2. Let me copy this down first. All right, and so I wrote this down in the paper here real quick. So what you want to do is you're going to multiply R1. And by the way, the row that's getting replaced here is R2. So R1 is going to stay the same, and R3 is going to stay the same. What you're going to do is you're going to multiply row 1 by -5. And then you're going to add the corresponding element of R2. So -5 times 1 is -5 plus 5 is 0. -5 times 1 is -5. -5 plus 9 is 4. Negative 5 times negative 4 is positive 20. 20 plus 7 is 27. Negative 5 times negative 8 is 40. 40 plus 4 is 44. And so this will be your new matrix. So I'm going to have 1, 1, negative 4, negative 8, 0, 4, 27, 44, and negative 6, 6, 8, 3. Okay. All right, question 5. Now we're going to perform these operations. Okay, so I wrote down some notes to kind of keep you from getting super bored here. Rows 1 and 2 are not going to change here, so I'm going to go ahead and copy those down. 0, 1, negative 3, negative 4, 0. It's these two rows that are going to change. So for this row 3, I'm going to multiply row 1 by negative 3, and I'm going to add row 3. So negative 1 or 1 times negative 3 is negative 3, plus 3 is 0. Negative 3 times 1, negative 3, plus row 3 be negative 3. Negative 3 times 1, negative 3 plus 4 is 1. Negative 3 times negative 1 be positive 3. 3 plus 5 is 8. Negative 3 times our row 1 be negative 15 plus 11, negative 4. And then now for the last row, you're going to do negative 6 times this row plus R4. So negative 6 times 1 is negative 6 plus 6 is 0. Negative 6 times 1, negative 6 plus 3 is negative 3. Negative 6 times 1 is negative 6. Negative 6 plus 5 is negative 1. Negative 6 times negative 1 is positive 6. 6 plus negative 7 is negative 1. And negative 6 times 5 is negative 30. Negative 30 plus 9 is negative 21. So it is a little tedious. Hopefully I didn't make a mistake there. And they're kind of prepping you for the next steps here. So 1, as I said, didn't mean to. The top two are not going to change. Negative 1 and 5. 0, 1, negative 3, negative 4, 0. And then the next two are, so 0, negative 3, 1, 8, and negative 4. And then we have 0, negative 3, negative 1, negative 1, and negative 21. Okay. Surprised I've gotten this many right in a row. All right, 6, we're going to solve using matrices. Okay. I went ahead and wrote down this problem and the resulting matrices here. So the first thing I want to do is I want 1 in the top corner. This has to be 1, and it is 1. Now I need to get these two to be 0. So I need to make these 0. Make 0. So how can I make this 0? I can do 2 times the first row minus the second row for that one. That'd make that 0. And then I could just add the first row and the third row to get that one to be 0. So the top row won't change. And this would be 2 times R1. 2 times 1 is 2. 2 minus 2 is 0. 2 times 1 is 2. 2 minus negative 1, that'd be 3. 2 times 1, or negative 1 would be negative 2. Negative 2 minus 1 would be negative 3. 2 times negative 3 is negative 6. Minus that 0 would be negative 6. And then here I'm just going to add them. 1 plus negative 1 is 0. 1 plus 3 is 4. 1 plus negative 2 is negative 3. Negative 3 plus 1 is negative 2. Okay, and so I've got those to be 0. Now, I need to make this be 1. Make this 1. So how can I do that? I'm going to do 1/3 are, I'm going to do 1/3 row 2 here to make that 1, because 1/3 times 1. So top row is not going to be changed. 1/3 times 3 is 1. 1/3 times -3 is -1. -2. I have 0, 4, -3, -2. Now I need to make this 0, so make 0. I'm going to go back to this top with the second row, okay? So if I do 4 times row 2 minus row 3, so 4 times 1 minus that would give me 0. So I got to try to think, how can I zero it out with that element? So if I do 4 times that and subtract them, it would work. So the top 2 rows, or the first 2 rows are not going to change. 0. And I don't want, I'm using the second row because I don't want to bring this 1 into it. So 4 times 0 is 0, minus 0 is 0. So 4 times 1 is 4, minus 4 is 0. What, there's a 1 here. Sorry. 4 times -1 would be -4. Minus -3 would be -1. Okay. And then 4 times -2 is -8. -8 plus 2 would be -6. Okay. Now, next, I need this to be 1. So need to make this 1. So how can I make it 1? I could just do -R3, because multiplying by the negative would make it positive. So row 1, row 2 does not change, and row 3 would become 1, be 1, and that -6 times -1 would be positive 6. So let's see if we can find that one on there. I've got 1, 1, -1, -3, 1, -1, -2, and 1, 6. Hallelujah. Now I'm going to use back substitution, okay? So this is the easier part. This is the easier part. That was the harder part. So my last element, I got to make 2 equations, or 3 equations. X plus y minus z equals -3. Y minus z is equal to -2. And then z equals to 6. So z equals to 6. I'm going to start there, and I'm going to substitute it back into that. So now I'm going to have y minus 6 equals -2. Add 6, y equals 4. Okay, and now I'm going to plug this and this back into the original, or the top one. So x plus 4 minus 6 equals -3. X minus 2 equals -3. Add 2, x equals -1. So my solution is -1, 4, 6. So -1, 4, 6. So, yeah, bro. All right, I got to make these be 0. So how can I make these be 0? I could do row 1 minus row 2. If I do 1 minus 1, 0. And row 1 minus row 3, because 1 minus 1, 0. So I make those 0. Because these must be 0. Okay? So the row 1 will not change. This becomes 0. Row 1 minus row 2. 1 minus -1 is -2. 1 minus -1. That'd be positive 2. Actually, this would be positive 2. Excuse me. 1 minus -1 is positive 2. -5 minus -1 would be -4. And then 1 minus 1, 0. 1 minus -1 is 2. 1 minus 1, 0. -5 minus -9, be adding the opposites of before. Now I need this. This must be 1. So how could I make this 1? Do 1/2 of row 2. So if I do 1/2 of row 2, 0, 1, 1, -2, and then this does not change. Next, what I'm going to do is I want to make what's underneath here. This must be 0. So must be 0. So what I could do is I could do 2 times row 2 minus row 3. 2 times 1 is 2, minus 2 is 0. So the first row does not change. Second row does not change. So 2 times row 2, 0. So here, 2 times row 2 be 2, minus 2, 0. This is 1 here. So 2 times row 2, 2 times 1 is 2, minus 0 is 2. And then finally, 2 times negative 2 is negative 4, minus 4 is negative 8. Now I need this to be 1. So this must be 1. So if I do 1/2 of R3, that would be 1. So 1, 1, 1, negative 5, 0, 1, 1, negative 2, 0, 0, 1, negative 4. So now for reduced row echelon form, what I've got to do is I've got to make now the values above, these have got to become 0. So I've got to make these 0. Make equal 0. Okay? So to make these equal 0, first thing I could do is, on this one I could do row 2 minus row 1, or row 1 minus, I'm going to do row 1 minus row 2. So row 1 minus row 2. So I'm going to do row 2, or row 1 minus row 2. Okay? So as I do that, the second row is not going to change. Third row is not going to change. The first one, 1 minus 0 is 1. 1 minus 1, 0. 1 minus 1, that's 0. Negative 5 minus negative 2 would be negative 3. Okay? Next, so these two are not going to make this 0. So going to make equal 0. So what if I did R3 minus R2? Or let's do R2 minus R3. So R2 minus R3, because I want to make this, so R2 minus R3. So 1, 0, 0, negative 3, 0, and then row 2 is 1 minus R3 is 0, 1 minus 0, 0, 1 minus 1, 0. And then negative 2 minus negative 4 would be positive 2. And then that gives me reduced row echelon form. So I'm going to have 1, 0, 0, negative 3, 0, 1, 0, 2, and then 1, negative 4. Okay. So the solution set, x is negative 3, y is 2, and z is negative 4. Negative 3, 2, negative 4. No. All right, I'm cheating on 8. I'm doing 8 in the calculator. So the first thing I'm going to do is I'm going to write down the equation, the coefficients. So 1, negative 1, negative 1, 1, negative 4, 2, negative 1, 2, 3, 9, 3, 1, negative 2, negative 3, 16, and 1, negative 3, 2, negative 3, 18. So I write down the matrix form, the matrix first. And then what I'm going to do is I'm going to use my calculator here. Okay, so I'm going to press second. Let's see where to write this at. So second x inverse, which is matrix, and then edit, and then A, matrix A. write down the steps for you. So second matrix, edit A. You want A to be a 4 rows by 5 columns, so 4 by 5. Now we're going to enter the elements into the matrix. So enter elements into the matrix. So I've got 1, -1, -1, 1, -4, 2, -1, 2, 3, 9, 3, 1, -2, -2, -3, 16, and -1, 3, 2, -3, 18. And after this one, we'll do second mode to get out of here. So second mode. And then we're going to do second X inverse, which is matrix. Then we're going to go to math, and we're going to do REF, which is reduced echelon form, which is A. And then we're going to enter matrix A in there. So second X inverse, which is matrix. And we're going to select matrix A. So second X inverse, select A. And then you get, now I'm going to do math, enter. Math, enter. Enter to make it a fractions. This makes it fractions. To make fractions. So this is my reduced echelon form. So RE, reduced echelon form, would be 1, 1/3, -2/3, -1, 16/3, 0, 1, 2/5, -6/5, 7, 0, 0, 1, 3/4, 5/2, and 0, 0, 0, 1, -2. Okay, so let's see what we've got here. So the last one needs to be -2. These are in different forms. So the solution is going to have to be this one, because you have to have 1s down the diagonal and 0s underneath. So it's equivalent to what I have. So the solution set, so if we go off of this, this means Z equals -2. This next equation is y plus 3/4 z equals 5/2. Well, z is -2, so y plus 3/4 times -2 equals 5/2. So y minus 3/2 equals 5/2. Add 3/2, add 3/2. Y equals 8/2, which is 4. So z equals -2, y equals 4. Now we're going to find x. So we know that x plus 2, this is, so you go back up here. So 2/3, I can't remember my writing. 2/5. So 2/5 times 4 minus 6/5 times -2 equals 7. So 2/5 times 4 minus 6/5 times -2. That's 4. So x plus 4 equals 7. Subtract 4, x equals 3. And now to w. So w is 1/3 x, 1/3 times 3, minus 2/3 times 4, minus -2 equals 16/3. Let's figure out what this is. So 1/3 times 3 minus 2/3 times 4 minus -2. So that's 1/3. W plus 1/3 equals 16/3. Subtract 1/3, subtract 1/3. W equals 15/3, which is 5. So my solution set's going to be 5, 3, 4, -2. So 5, 3, 4, -2. 5, 3, 4, -2. All right, let's try the next one. So using Gaussian elimination with back substitution. So let's do the same thing we did on the last one. All right, so for this problem, I'm going to show you how to do this problem using reduced row echelon form. So I've written this problem down on my here, and I've written down directions. So what I'm going to do is I'm going to go to second matrix, edit. I'm going to enter these elements in here. It's a 4x5 matrix. So 4, -3, 1, 1, 4, 1, -1, -1, -1, -1, -2, 3, 1, -2, -2, -4. Let's pause it 4. And then -1, 3, 3, -2, -5. And I'm going to double check these here. Yeah. Now what I'm going to do is second mode to get out of here. Then second matrix, math, RREF, second matrix A. And so I get reduced row echelon form gives me 1, 0, 0, 0, 2, 0, 1, 0, 0, 2, 0, 0, 1, 0, -1, and 0, 0, 0, 1, 3. What does this mean? This means that z equals 3. That means y equals -1, x equals 2, and w equals 2. So my solution is going to be 2, 2, -1, 3. So 2, 2, 2, 2, -1, 3.